Welcome back to another video. Let's jump right into the topic of Bernoulli distribution. A Bernoulli process is a sequence of experiments or trials that each have exactly two possible outcomes. The trials are independent, meaning the outcome of one trial does not affect the others. Each trial can result in a success, usually denoted as 1, or a failure, usually denoted as 0. Examples include tossing a coin, success equals heads, failure equals tails, or whether a service call leads to a purchase, success equals purchase, failure equals no purchase. In the context of a Bernoulli process, we label one outcome as a success, denoted as 1, and the other as a failure, denoted as 0, where the probability of success is denoted by p, and the probability of failure is 1 minus p, since the total probability must sum to 1. As a result, the probability of a Bernoulli random variable or probability of observing a specific Bernoulli outcome in a single trial is given by p to the power of x multiplied by 1 minus p to the power of 1 minus x, where the two possible outcomes for x are 0 for failure and 1 for success. The expected value or average of the outcomes in a Bernoulli process is equal to the probability of success p. This is because each trial has a success probability of p, and the outcome is either 1, success, or 0, failure. The variance of the outcome is a measure of how spread out the results are. For a Bernoulli process, the variance is given by the p multiplied by 1 minus p. This makes sense because the product of probabilities of success and failure captures the likelihood of both success and failure happening, and the spread is widest when both are equally probable. On the other hand, if p is close to 0 or 1, the outcomes are less spread out. You know the outcome will almost always be failure or success, so the variance is low. Here, we can see the difference between two Bernoulli distributions. On the left, we have an unfair coin which has a probability of 2/3 in heads, success, and on the right side we have a fair coin which has a probability of 1/2 in heads, success. These two Bernoulli processes have different PMFs, means, and variances. The unfair coin has a mean of 2/3 and a variance of 2/9, while the fair coin has a mean of 1/2 and a variance of 1/4. Can you explain why the fair coin has a higher variance? Here you can see how we can use Python to calculate Bernoulli PMFs and visualize them. We can use the Bernoulli function to model a Bernoulli distribution. Here as an example, I have calculated the probability of observing a tail on an unfair coin which has a probability of 2/3 in heads in the last line of the script. You can also see how to use Python to visualize Bernoulli distributions. Thank you for your attention, and see you in the next video.